Exercise 12. We're doing yet another mass percent problem, empirical formula and molecular formula problem. But this one is big enough that we're going to stick to the list method, right? We've already showed you, or I've already showed you, two examples of using just your typical conversion factor strategy. This particular problem is going to have 4 different elements present. So let's go ahead and let's use the list, right? Let's see how the list works. Give you an example about how what you need to write on the AP exam to get full credit if this is the strategy you choose to use, which is totally legit, by the way. So caffeine, a stimulant found in coffee. No one knows what caffeine is. No one here consumes coffee, tea, or chocolate, or energy drinks constantly, whatever. Contains 49.48% carbon, 5.15% hydrogen, and 28.87% nitrogen, as well as 16.49% oxygen by mass. Again, percentages, let's assume 100-gram sample. That's what we're going to do. And that's going to allow us to magically transform these percentages into grams. Now, like I said, we're going to use the list strategy here. I'm going to use the calculator. So I have carbon, hydrogen, nitrogen, and oxygen. And by the way, I'm writing exactly what you would want to write on the AP exam. Again, not because there's a specific form you have to use, but remember what the AP graders are wanting to see. They're wanting to see evidence that you know what the process is supposed to be. Now, they know that you're going to be using a calculator, right? They know that these graphing calculators are allowed on the AP exam, but they still need to see evidence of what you're doing. And let me show you how to do that. Nice combination of going quickly and still showing all of your work. So, list 1. I don't know why I wrote an I. List 1, right, is going to be the mass of each element that we have, right? Because that's a gram, 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 gram. We have masses of 4 different elements here. So let's write those down. So for carbon, we have 49.48. For hydrogen, we have 1.51, right? These are grams, right? Mass. For nitrogen, we have 28.87 grams. And then for oxygen, we have 16.49 grams. And what I'm going to have to do here is I'm going to have to divide by the molar mass, just like we did back in exercise 10. Now the molar mass of carbon, I remember that, 12.01, 1.01 for hydrogen, 14.01 for nitrogen, and 16.00 for oxygen. Now these are all grams per mole, and I want to write that down because L2 is my molar mass. So see what I'm telling the AP grader. I'm taking the mass, which I've already assumed there's a 100-gram sample. I'm taking the mass, and I'm dividing it by the molar mass. I'm dividing by this. I'm dividing by that. So that is going to tell the AP grader that I'm flipping these units, and so I'll carry out the function that I'm supposed to do, even if I was doing regular old conversion factors. And so that is going to be our L3, right, which is going to be our number of moles. And so how are we going to accomplish that? L3 is equal to L1 divided by L2. Do we remember that? Yeah, let's do that. So L3, all right, let's get my calculator loaded back up. Turned off for a moment for some reason. All right, so now we've already done a list problem, so we have list data in our calculator. These things store any list that you've already used, so we have to make sure we clear our calculator before we do any problem where we use lists. So the way you do that is get to the memory function, second, memory, which is the plus button, so second, plus, and then you're going to go clear all lists, which is number 4, press enter, done. So all the data that was already in those lists is gone. So when I go to stat enter, I have empty lists ready for me to input. So list 1, 49.48, enter. 5.15, enter. 28.87, enter. 16.49, enter. That's it for list 1. List 2 is 12.01 because that's carbon. Hydrogen is 1.01. Nitrogen is 14.01. And then oxygen is 16.00. Now, getting over to list 3. Remember, you got to scroll up to highlight list 3. Press enter. And now you can tell the calculator that you want list 3 to be list 1 divided by list 2. And we get this data. So let's copy that down so we can show our work. All right, we have to show the AP graders what we're doing. Let's see, how many significant figures do I want? Let's go 4s. I'm going to use 4 on these. So 4.11, no, 120. And then 5.099, and then 2.61, and then 1.031. Is that right? Okay. So remember, now I have the number of moles. So for every this number of moles of carbon, this number of moles of hydrogen occur. But we can't put these numbers as subscripts in our empirical formula because they're not integers. We need integers. And so what we do is we pick the smallest number out of this list, and we divide all values within this list by that smallest value. So what is the smallest value? This one right here. So my list 4 is going to be simplifying. Okay, so I'll go over one more, scroll up to list 4. So I want list 4 to be whatever list 3 is divided by, what's my smallest value here? 1.0, let's just do the whole thing. And so you can see here that I have these values that, well, here obviously is a 1, but are insanely close to whole numbers. So this is, 4. This one is 5. This one is 2. This one is 1. Now hopefully you can see that. 3.9976, that's 4. 4.9476, that's 5. 1.9995, that's 2. Right? So 4, 5, 2, 1. And so what this tells us is that the empirical formula for this substance is C4H5N2O1. But let's go back to the problem to make sure that we're doing what we're supposed to be doing. It says determine the molecular formula for caffeine. Notice in this problem, we're not necessarily getting a point for the empirical formula. It's simply a midpoint that we have to go through to get to the molecular formula. So, so if the empirical formula has a particular mass, the molar mass of the substance is known, right? It's right here. So I'm going to calculate the mass of this bad boy and see how it compares to the mass of the actual molecule. So there are 4 carbons. There are 5 hydrogens. There are 2 nitrogens. And there's 1 oxygen. So that comes out to be 97.11. So the mass of the empirical formula is 97.11. Well, the mass of the substance, whatever it is 194.2. Let's divide it by the number we just established. Oh my gosh, look, it comes out to be 2. It's 2. So the molecular formula for this is going to be 2 times everything that's already here. So C4 becomes C8. H5 becomes H10. N2 becomes H4. And O1 becomes O2. Now I'm going to box out that molecular formula because remember, the question, after all, is asking me to determine the molecular formula for caffeine.